Okay, friends, good evening. Hello.
Good evening, sir.
Good evening to everyone. Right. So we will commence the class. Here is a numerical for you. Please handle this. If you have any questions, any issues, please ask.
That's it.
If you need any help, please ask. And you should give me convincing answer.
Yes. Sir, can you explain that what is longitudinal gradient?
Good. How many students have that doubt here?
Sir,
Now, see, when you encounter something like that, as I told you, knowledge begets knowledge. And from knowledge you can get knowledge. And you should try to relate, because in, say, final examination also you might encounter this problem. Now, you have come across this word velocity gradient. Where have you come across this word?
Viscosity.
Pardon?
Viscosity.
Viscosity. Okay. So, do you remember some diagram which explained this?
Yes.
What is the diagram?
There are 2 layers of liquid, sir.
Just 2 layers? Just 2 layers? See, you had, assume that this is the river. I'm just showing you the river. So the river is flowing like this, right? I suppose all of you remember this. And then you have studied quite a bit of theory in that. So what is that? So supposing you draw a line here and start showing the vectors. What is this? This is the velocity vector. I suppose you remember.
yes.
Hello?
Yes, sir.
Yes.
So
Yes.
what are these vectors? These are the vectors which are representing the velocity. Velocity of the layers. Correct?
Yes, sir.
And this is representing the x direction. This is representing the x direction. So the velocity here is 0, and the velocity here is v1, v2, v3, v4, v5. And say this is position x1, x2, x3, x4, x5. Correct?
Yes, sir.
You recollect this. And then what did you see here? The difference in the velocity v2 minus v1 will be x2 minus divided by x2 minus x1. So this we write it as delta v by delta x. And we call this as the velocity gradient.
Yes,
Correct?
sir.
So why do you get this, have this phenomenon? Because this layer of the fluid which is moving is obstructed by the immediate layer of fluid. Understand? It is obstructed. So there is friction between the layers of the fluid. There is friction between the layers of the fluid, and this friction we call it as viscous friction. Correct?
Yes.
And the viscous friction is proportional to the velocity gradient. That is precisely what you have learned.
Yes, sir.
Now, look at this diagram. Streamline motion. So, this you have learned under the heading called streamline motion, viscosity. Streamline motion is a motion in which there is only longitudinal velocity gradient.
Yes.
Radial velocity gradient. So now if you look at the river, say the river is flowing in front of you. So you will find the velocity gradient like this between different layers. Now do you see it like this? The velocity is increasing radially like this. Or do you see it, velocity is increasing in this direction only, isn't it?
Yes.
Velocity here, velocity here, isn't it? So, and the flow is longitudinal. Longitudinal, isn't it? And the velocity gradient here is also in this direction. Understand?
Upward direction.
Okay, upward direction. Okay, you can
And
take
can
it
be
longitudinal also, isn't it? But definitely it is not radial. See, radial means it would not be radial, because radial means, see, you must be getting the circles. See, the velocity here, the velocity here. Will it happen? See, if you go to a river, will it happen like this?
No, it will not.
It will not happen like this, isn't it? It's not that, at some point the velocity in the river is zero and then the velocity keeps increasing down and up and this side, it doesn't happen.
Yes.
Common sense. So therefore, it is only along the longitudinal direction.
Yes, sir.
Right? And therefore, we say, well, streamline motion is a motion where there is only longitudinal velocity gradient.
Yes, sir.
Will you agree to this?
Yes, sir.
Okay. Still, you have some question you can ask.
Sir, if you consider a river which is curved,
No. See, streamline flow is when
it can be
it can be. See, Arun is asking a good question. Supposing the river is turning like this, then how will you show this, sir?
Sir, when you will draw the streamline, sir, then sir, we know that the tangent to the streamline will give us the velocity of that velocity at that point, sir.
Excellent.
So if we will draw the streamlines, we will observe that they will be a partial curve, but they'll never be closed loops because streamlines can't cross each other.
So whatever explanation I have given, is it convincing?
Yes, sir.
See, I am sure you are not applying your mind. See now, in streamline, no, I don't think you are applying mind. I gave you something like streamline motion, velocity gradient, I showed. But here the question is, streamline motion is that motion where there is. Now they are asking streamline motion. We are not discussing viscosity. We are not discussing viscosity. Clear? Right? So now, whatever I have said, I don't want you to blindly accept it. It should convince you. Like Arun sitting here is asking a very good question. Sir, if the water is curving, say it is going in a curve, then how will you define this? It is not longitudinal.
it is longitudinal and radial goes.
It's longitudinal only, sir.
Listen, you didn't get that idea. All of you think. See, now what does streamline flow means? Say, there is water flowing here. Okay, now you will mark some points, P1, you will mark some points P1, P2, P3, P4, okay, P5, like this you are marking some points. Now, come on, now relate the streamline flow to these points.
Streamline means it is the line in which all the particles will.
It's not a line.
It's a trajectory.
No,
of
I am showing you some points. The water is flowing streamline, and in the streamline flow, I am showing you the points P1, P2, P3, P4. Now tell me what is happening at P1.
It's moving particles.
No, P1 is not particle. P1 are points. P1, P2, P3 are
all the
points.
particles in that streamline will pass through point.
No, whichever particle passes through this P1 will have velocity V1.
Yes, sir.
Particle P2 will have velocity V2. Particle C. Now imagine water is flowing. So there are many particles of water.
Yes.
So the particle that comes here will always have velocity V1.
Yes, sir.
See, the streamline can be like this also.
You can.
Right? So now what it means is, the particle which comes here will have certain velocity. Whichever particle comes there will have velocity V1.
Yes.
And here there can be a streamline like this, right? Here there can be a streamline like this. Here there can be a streamline going like this. So what it means is, at each of these points, if you go to those points, and measure the velocity, it will be same.
Throughout that.
Yes, throughout the same.
Yes, sir.
Correct, no?
Correct.
The velocity will be same at these points. That is how we start with the streamlines. The velocity at this point, velocity at this point are same. Now, velocity here is V1 bar. Velocity here is V2 bar. Velocity here is V3 bar. They are different at different points. Okay. Now, when you go to another point here, say another point here, the velocity here can be say V5 bar. The velocity here can be V5 bar. So therefore now what you can see here is, well, the velocity here and the velocity here, okay? And supposing you say that the distance between it is delta x, and the variation here is delta v, correct? So delta v becomes what? The change in the velocity.
Yes.
And delta x becomes what? The change in the
Position.
correct?
Yes.
And this becomes what? Velocity gradient in the horizontal direction.
Yes, sir.
So here you see what I had given explanation here was for viscosity. So here you see the velocity gradient, the direction of the flow of the liquid is like this. The velocity gradient is transverse. See, you have studied waves,
Yes, sir.
correct? See, you have studied transverse wave and longitudinal waves. So what is longitudinal waves? Huh? Well, you see, along the direction of flow, the particles are vibrating. Transverse waves, it is perpendicular to this. See, what I am trying to tell you is, you have learned quite a bit of physics. Try to use it. And even if some book or somewhere, some teacher or some friend gives an explanation, you should not take it in the face value. You should apply yourself. Right? And that's why I tested all of you with this. Yes, but I am very happy that Arun sitting here said, sir, if you say it is going to be like this, if the river is turning like this, then what you have explained here doesn't make sense. Good. So now what I have said, does it make sense?
Yes.
So here in streamline motion, the motion in which there is only longitudinal velocity gradient. I think that holds good.
That holds good.
Correct?
It holds.
Yes, Sudheer.
So if you take the curved path in which the streamline motion is happening, sir,
Correct.
water is flowing.
Yes.
Now, if you consider the velocities along that cross section, right?
Correct. So you are telling now.
There is very variation velocity.
So you are thinking that the river is flowing like this.
Yes, sir, correct.
River is flowing like this. Again, here you mark the points here, this point and this point. Now when you say longitudinal means it is parallel to the direction of the motion. Okay, see the water in this point is moving in this direction and you are measuring in this direction. So it qualifies for longitudinal motion.
So if you take the motion like radially outwards, like
Radially, you think though, radially outward, can it happen like that?
Not all.
See, it should. See, now radially means it should happen in all directions. Is it happening like that? That the velocity is spreading like this?
It can happen.
It can happen, but not streamline motion.
It is called streamline motion.
Listen here. Now you have now streamline motion, right? Now see, now when we are defining streamline motion, we are saying, okay, the fluid is flowing here like this. It's not that it is diverging from a point or something like that. Correct? So therefore the answer is A. Do you all agree?
Sir, also when we are defining streamline motion, we are considering steady flow, sir.
Yes, steady flow is also correct. Steady flow is correct. Okay, will you all agree? It is A?
Yes, sir.
Hello?
Yes, sir.
Yes, sir.
Let me see the option. Which is this problem? 57. A is the option. Okay? Done. Right. It's good, please discuss. And I like, because don't go by whatever I say. See, the truth will always appeal to heart and head. So if it doesn't appeal, then yes, sir, there is something wrong, you should ask. Done. An aeroplane of mass so and so and a total wing of so and so is at a level flight of 7 feet. The difference between the pressure in the upper and lower surfaces of the wing in kilopascals. So I suppose all of you know aerofoil,
Yes, sir.
Bernoulli's
Yes.
equation,
Yes, sir.
right? So now, okay, now solve it. If you have understood, you can solve this. If you cannot solve, then let me know why you cannot solve this.
Done, sir.
What is your option, gentlemen?
Option A, sir.
You got option A. Let me see. Others also solve.
Sir, can I tell my logic, sir?
No, wait. Others are solving. Did I ask you?
Okay, sir.
You are putting pressure on others unnecessarily. Okay, others are taking pretty high time. You also got?
I couldn't differ.
Shall we? Why you should delta PGDBA, what is it?
Sir, I don't believe force on April should be equal to force on the downwards. So it will fly next.
Okay, fine. Okay, friends. Okay, some of you are not able to solve at all for whatever reason. So those of you who cannot solve, just you draw the aeroplane wing. I suppose. Right? You draw the aeroplane wing. Hello?
Yes, sir.
Now you say the air from here starts moving.
Yes, sir. Crowded on the top, less crowded.
Okay. This say per unit time m kilos of air will enter this point. M kilos of air will enter this point, and how much air will come out of this point?
Has to be there.
Same.
It has to be same, correct?
Yeah.
But now you see some particles of air will take this path, whose length is L1. Some particles will take this path, whose length is L2. Now whatever particles entered here, the same particles will come out see it has entered at time t1. All these particles will come out at time t2. Do you agree?
Yes, sir.
Same particles, not different particles.
Yes, sir.
So that means now those are the particles which took this path along L1 will have average velocity L1 by T2 minus T1, and those particles which went upside will have velocity T2 minus T1. I suppose all of you know this. Hello? So therefore, if I say this velocity is V1 bar, this velocity is V2 bar, okay, I just use speeds, not velocity, speeds. So therefore now it is very clear V2 is greater than V1 because it has to cover larger distance in shorter time.
Yes, sir.
Right. Now, because of this, what happens?
There will be an uplift force.
Why?
Because the streamlines will be crowding on top, sir.
No. Streamlines will be crowding on top. I don't agree. See, it is a streamline crowding is a way of representing something else, some physical quantity. Why will now V2 is greater than V1? We have established this.
Yes.
Okay. Now go to the next step and tell me.
Sir,
Yes.
as velocity air above this higher, sir, so there will be a low pressure area.
Why there will be low pressure area?
Because all the molecules will be clearing out.
No. Why there will be low pressure area on top?
Because some molecules will be having some kinetic energy more over there, sir.
Correct. Because V2 is more, kinetic energy is more. Correct.
So,
Sir, because of Bernoulli spectrum.
Only one boy is thinking in the right direction. Only one student is thinking in the right direction. Others are simply, you are beating around the bush and showing your brilliance because of Bernoulli's principle. Correct. Now, Aryan, you tell me, how will you apply Bernoulli's principle here?
Sir, on the above, sir, the velocity, that is the speed of the particles will be more, sir. So to maintain the constant, sir.
So supposing you are Aryan, supposing you are a teacher and you have to explain this to someone. How will you explain?
Sir, by Bernoulli's principle, sir.
Huh.
Now the particles which are on the top of the airplane, sir.
See now, you have understood very well. What if you tell, sir, consider this point here and consider another point here. For this point, you write the equation P1 plus what shall I write? Rho V1 square, right? Continue. Okay, V2. Continue.
First,
Rho G H2.
is constant.
That's what you are going to write. That's how you are going. That's how you are going to explain somebody.
Sir, you should write for L1 also.
So the next thing is, sir, write the Bernoulli's equation for this. P1 plus half rho V1 square plus rho G H2.
Rho G H1. Yes.
H1. Okay.
Now we know, sir, that V2 is greater than V1. So is
No.
H2.
Hey, don't jump to conclusion. So you have written two equations. Now what will you do next?
Equate them.
You equate them, isn't it? Because see, the same. That's why I started. The same set of particles are moving in both directions. So you will equate it. That is, this is just like a pipe. This is just like a pipe. You know, the same thing is going, but at two different points. And here also there is streamline. Okay. So you are going to equate this to this. Right?
Yes.
You are going to equate this to this. Now, what is the next step?
So we know that V2 is greater than V1. We also know H2 is greater than H1. Which means to maintain the constant, the pressure energy on top has to decrease.
Listen. Now V2 is greater than V1, H2 is greater than H1.
Yes, sir.
By how much is?
P1 plus P2 has to be a positive.
Listen. Now here, what is H1 and H2 here?
So H1, you take some reference level. From that,
You will complicate the situation. So this is a aerofoil. So for all practical purpose, this distance can be taken as C. So here H1 is equal to H2. Understood?
Yes,
For all practical
even if that
purpose.
is
So
the case,
listen. You should go by that. Then only you will get it. So take it off. Okay. Now if this is to be equal to this, now V2 is greater, then P2 must be less.
Yes.
V1 is greater, P1 must be greater. Therefore, there will be a pressure gradient in this direction.
Yes, sir.
Correct? We establish a pressure gradient in this direction
Yes.
because of the velocity difference.
Yes.
That is fine. Now, okay, pressure gradient is this. How will this get converted into a force, a lift? How will this lift the aircraft? There is pressure gradient.
Yes.
Explain.
Now when there's pressure gradient, sir, that streamline will try to go from high pressure to low pressure.
Come on, yaar. See, this is the problem with you. You should not. You only tell. What is that? Here the aerofoil is there. Pressure will go from here to there. Means what? See now. See. You go in steps, man. You should use physics and logic. Here you have established by Bernoulli's theorem that there is pressure gradient. Now my question is, how will this pressure gradient lift the plane?
So there is the pressure above the aeroplane is less than that of below, sir.
That is why there is delta P.
Sir, so there is net pressure acting upwards.
Okay.
So if the net pressure is acting upwards, sir, so that means some force acting upwards.
You have now you have to talk in terms of force. So if the aeroplane is to be balanced, that means the weight of the aeroplane is down.
Yes.
This is balanced by this pressure, but pressure cannot balance the force. But you have to see how this pressure will manifest as force. Correct?
Yes.
How this pressure will manifest as force?
It's by unit of field.
Yes, area of the cross section. So this will manifest as force. This is precisely what you have given. Correct, no?
Yes.
Then you should explain like this. You should explain. See, every step, you should use physics and explain this. So now here you see mass. So here this is given, this is known, right? This is also given, and then they have given you the area, okay? And then they are asking you the pressure difference between them. So they are asking you delta. So here the mass is 3 into 10 to the power of 4, and T is 10, and area is 120. Right? So they are asking you in kilopascals. So 1 Newton per meter square is 1 Pascal. Okay? So obviously this we are going to knock off, and this will be 4. So this will be 1 by 4 is 0.25. Correct? 0.25 into 10 to the power of 4. So this becomes 2.5 into 10 to the power of 3 pascals. Or
Yes.
2.5 kilopascals.
Yes.
See, I want the signs at every step. I know many of you would have solved this problem and you would have directly written this formula. But I am sorry to say, none of you explained how you were able to, at each step of it, how it is. Although I know that you know, it's not that it's way, but you should train up like this. Because in some situation it is direct, but in some other situation it need not be so direct. Okay, so please learn like that, and whenever you solve problem, please rehearse like this. Just don't write formulas and get the answer. Think like this. Then your science will become stronger. Wait, shall I proceed?
One not.
Yes, please.
Here, delta P is independent of height, no?
Delta P is?
Independent of height.
Yes,
it is there.
yes.
So why will it like move upward and stay at a particular height?
Why will it?
Like stay at a particular height, so like there will be always some network.
Why will it move up and stay means I didn't get you. What are you trying to tell me?
No, sir, I was asking why like it will stay at a particular height, why it will not move forward.
It will move forward. See, you should know that in aeroplane, what are all the forces acting in aeroplane? One is the weight. It is balanced by the lift.
Yes, sir.
Okay. And the other force is the force of the plane. Engine force. Right? And the other one is the air friction, which you call it as the drag force. So this is the drag force, this is the engine force, and this is what it is. Correct? And all the forces are equal. Right? See, if this force balances this force, okay, then net force is 0, it will be moving with uniform velocity. If this force is equal to this force, it will neither go up nor go down. Say the pilot wants to accelerate it, then he will make this vector more. Right? Then velocity will increase. And then there are propellers, of course jet engine propeller is different. Then he will, there are ways and methods of it. Okay, by which you can maneuver. Anyway, I have not discussed that in detail now. I have discussed that in detail in my theory classes. Okay, shall I proceed?
Yes, yes.
Yes.